Okay, as promised, I'm going to work through, I have 10 problems here that are gravitational potential energy problems and kinetic energy problems. And as you notice, the formulas are right here. Okay, so we'll work through some of these. Alright, beginning with number 1. What is the GPE of 5.5 kilograms raised to a height of 14 meters? And again, one of the first things I do is what is given to me. So I'm solving for can't type today, PE. GPE equals what? And I have a mass of 5.5 kilograms. And I have an H, a height of 14 meters. And G, once again, it's that constant, unless I tell you we're in outer space or another planet, is going to be 9.8 meters per second squared. Where's my Okay, so working through the problem then, GPE equals 5.5 times 14 times 9.8. I'll pull up my handy dandy little calculator here. And 5.5 times 14 times 9.8 equals 754.6. So in this problem, GPE equals, pull my calculator again, 754.6 joules. Okay. Excuse me. Okay. There. That's problem number 1. In problem number 2, it says, problem number 2 asks, what's going on here? I don't want to save my ink notes. Problem number 2 asks us, determine the KE. So KE equals question mark of 1040, so M equals 1040 kilograms. V equals 22.0 meters per second. Okay, plugging it into our formula, KE equals 1/2 times M, which is 1040, times 22 squared. We're going to insert that symbol. Squared. Okay. So KE equals. First thing I do when I solve these problems, let me clear this out, is I square V. So 22 squared. Where's my square key? Let me get a different calculator here. 22 squared is 484. So I have 1/2. And then Then I'll take half of M. So 484. I'm going to write that down. 484, just so I have it down there. 1/2 of M. 1040 divided by 2 equals 520. So KE equals 520 times 484, and that would equal, clear that out, 520, I already have it there, times 484, 484 equals, and there you have the answer. Apologize that I can't leave it up there. 251,680. 251,680, and again, joules. Okay. Next problem. If a roller coaster in the above problem were moving with twice the speed, by what factor would KE increase? Let's increase the speed. So KE equals 1/2 times the M of 1040 times, it says if we're moving at twice the speed, so we're going to double the speed from 22 to 44. Oops, 44. We still have to square it in the problem. Okay, insert a symbol, squared. Okay. So KE equals, again, pull up my calculator, square 44, let me clear this out, 44 squared, I'm going to write that down somewhere in what was that number? 1936, 1936, take half of M is 520, so KE equals 520 times 1936, should have 1936 up there already, times 520 equals, and what was the number? 1006720. 1006720. Okay. To compare the two, we have two, and that, oops, excuse me, first I better put my units in here, don't forget your units. So we have 251,680. Okay. To compare the two, we can divide. Hold my calculator, should still have it. Divided by 251,680, and that equals 4. So by doubling the speed, the KE is increased by 4 times, or okay, quadruples. All right. Leave that problem up there if you're still copying it. Okay. This one, Miss Dyewater, the former platform diver Ringling brother, had a KE of, so her KE equals 15,000 joules. Her mass equals 57 kilograms. Then her speed equals what? Okay. So V equals, and this might be a little hard for me to, hopefully I can draw it on here for you. V equals 2KE. I'll try and draw it on here for you. 2KE over M, and then it's the square root of all of that. Okay? All right. So putting our numbers back in. Oh, it's gonna. V equals 2 times KE is 15,000. Oops. And I'm going to 2 times 15,000 over, oops, let's see if it'll let me. Two over 15,000 divided by 57, and then once again, the square root of that. Okay. So the way I approach this is I'm going to do the inside and then take the square root of it first. So pulling up my calculator again, get it up out of the way. I have 2 times 15,000, okay, equals divided by 57. Okay, so then 526, and then see if this will let me do a square root. Where is my square root? Square root. There it is. Is that it? Yep. So, as you see there, then V equals, let's see if it'll let me, oh yeah. So then V equals, whatever that number was, 22.9, you can we'll round it to 23. That's going to be meters per second. Okay? All right. Next problem. What is the mass of a car? So M equals what? Oops. No way to give me caps. M equals, we're solving for M. And the KE equals 290,000. And V equals 52 kilometers per hour. Okay. Okay, and the reason that this is highlighted is it's not our standard units, so we're going to have to convert it, okay? So 52 kilometers to get to meters is going to multiply by 1,000. So there's 52,000 meters in a kilometer. And then there are 60 times 60, and just to show you, because we're at meters per second, I'm going to put my calculator. 60 times 60 equals 3,600. So it's going to be 52,000 divided by 3,600 seconds, okay? And that's going to equal, pull my calculator, clear, 52 to 3,000 divided by 3,600 equals 14.4 meters per second, okay? And like I said, I caution you, make sure when you're solving these problems, oops, make sure that you keep your units straight. All right, so punch it back into the formula. We have solving for M. M equals, if you remember when we did this on the board, 2KE. And 2KE divided by, oh, come on now, 2KE over V squared. Oops, insert my symbol. Okay. So M equals 2 times the KE of 290, commas 1, 2, 3, and that's going to be over oops. Do that again. M equals over, and my V is 14.4. Now where my line goes, this thing, I don't know. Don't quite have this figured out, gang. Okay, over 14.4, and that's squared. Squared. So again, like I said, I do the squaring first. So I can square that, 14.4, 208.6. All right, I'm going to write that down over here somewhere, 208.6. Okay, and then I'm going to go back and multiply the 2 by the 290. 2 times 290, 1, 2, 3, equals 58,000. Okay, so back to my problem I have. $58,000 divided by 208.6, and that equals 208.6 equals masses. Oops, I forgot to 2780.4. 2780.4 kilograms. Let's see if that makes sense. I always go back and make sure it makes sense. Mass of a car, that would be, multiply that by 2. That's a pretty heavy car. Most cars weigh about a ton. So that's a pretty car, because if you multiply that by 2, that car is about 5,000 pounds. So pretty heavy car. All right, number 6. What is the mass of a bowling ball? So M equals what? Okay, Knight always wants to convert it to M equals what? And our GPE equals 140J. Sitting on a shelf, the H equals 2.2. So this one again, solving for M equals GPE divided by everything else, H and G. Okay, so M equals 140 divided by H is 2.2 and G is 9.8. Okay, pull up our calculator. 140 divided by 2.2 divided by 9.8 equals, the M equals 6.5, we can say 6.5 kilograms. All right, pretty easy problem, straightforward. Number 7, what is the total potential energy? So, average force of 94 newtons. Okay, that is 1.6 meters off the ground. Okay, problem 7 is a little different in that they're asking, at least I think here, that they're asking for the total potential energy, and they're giving us, if you look here, they're giving us a partial one already. So the way I'm going to approach this problem is to say we have let's see, where are we at here? We're going to solve for total GPE. Okay, total GPE, so that we have an M equal to 86 grams, which would equal 0.086 kilograms. Remember what the units are. We don't need that 58 centimeters, and we can ignore that 94. We'll add that in later. And the arrow, the height is 1.6 meters. Okay, so again, we're going to solve for what we don't know, and they're already giving us a partial force. So we have a GPE of 86 times 9.8 times 1.6. Okay, for a calculator. So we have 8. Oops. Oh, I got to. Excuse me. There, I forgot. 0.086. 0.086 times 9.8 times 1.6 equals. So there we have a GPE of 1.3, we'll say. So GPE equals 1.3 joules. And then I'm thinking here, this problem is a little bit different, that we just, after the total GPE equals that 94 plus the 1.3. Okay? Alright. That problem, don't worry, that problem, you're not going to see one like that on your test. So a bear with a mass, M equal to 218 kilograms. And again, watch what they're doing. Oh, wait. Yeah. 218 kilograms. At the top of the hill, she's gained 23.5 joules of potential energy. How high is the hill? So GPE equals 23.5. How high is the hill? Okay, so we have 23.5 divided by 218 times 9.8. That's going to equal 23.5 divided by 218 divided by 9.8 equals. So the height equals, let's see if we did that right. MGH H equals GPE divided by everything else. Yeah. How high was the hill? The hill is, it doesn't seem right. So this doesn't seem right, but they're saying that the hill is 0.01 meters. I don't think this was. I think I changed that. Originally, I think this was kilojoules, so it would have been a lot more. But anyway, you see how to solve that problem. Okay, Number 9, a roller coaster starts at some height that you don't know. So h equals, we don't know. We don't know. We don't. H equals, we don't know. Goes down this hill and goes up a second hill that is 28 meters. Okay, so this is, we can say H. I'll put H, H1. Okay, it goes down this hill and then goes up a second hill that is 28 meters above the first drop. Okay, so H, why did it do that? H2 equals 28.5 plus H1, right? Above the first drop and at a speed V equal to 22.5 meters per second. So how high was the initial hill? Whoa. Same height that you do now, goes down a hill and then goes up a second hill. So GPE equals, wait once here. Oh, I'm sorry. KE equals what? Okay, I was looking at this problem, and this is a little different again. This is another problem that is a little more advanced than what we're working on. Combines the next formula that we're going to do of work, and we'll get into that in the next chapter. So you can disregard this problem, and we'll take a look at number 10 here. And that's, again, the number 10, disregard. So you should have enough there in problems 1 through 8. Again, if you're having trouble with this, you want more practice, just Google GPE. You can even Google GPE and KE problems. That's where I found this. And you should be able to go in and see how they solve them, and look for some examples of solving the problems, and you should have no trouble.